All right, so we learned how to draw skeletal structures and how to envision them in three-dimensional space. However, Lewis and even skeletal structures don't tell the whole truth about a molecule. So let's take a look at an example of this from a kind of Gen Chem in nitrite, so NO2 minus. So if you're to draw the Lewis structure for nitrite, this is what you might end up with. Right? And so this molecule looks like it has a double bond over here, and then a single bond over here, and then a negatively charged carbon and a neutral or negatively charged oxygen and a neutral oxygen. However, we learned that wasn't true and that we need to draw resonance structures for these compounds, right? And so you could draw a resonance structure for nitrite that looks something like this, right? Where we've flipped the double and the single bond, right? And this arrow right here, this double-sided arrow, is a resonance arrow. And so to say that one bond is single and one bond is double is not the truth, right? No. The real structure is a combination of the two, is a hybrid of the two. So the real structure looks something like this, right? Where we have this nitrogen with its lone pairs, and then we have two oxygens, and then there's these pi electrons that and this negative charge that are delocalized over these two oxygens, right? So these pi electrons are delocalized, right? They're not just on one oxygen, they're on both of them. And so when we draw Lewis structures and skeletal structures, not only do we have to envision what they look like in three-dimensional space, we have to think about what their resonance structures are and what the kind of real structure actually looks like. And then just one thing to note, remember that neither of these resonance structures are real. It's not that the molecule is jumping back and forth between the two. It's just that we have a limitation on the way we can write this, and that the real structure looks something like this.